Let's have the sample exercise. If birth weights in a population are normally distributed with a mean of 109 ounce and a standard deviation of 13 ounce, what is the chance of obtaining a birth weight of 141 ounce or heavier when sampling birth records at random? So let's try to answer this item first. Letter A. Let me just box this. Okay. And let's write the given values since the data involves a population, so our values are the population mean or our mu, which is equal to 109. We have our population standard deviation, which is equal to, or sigma, which is equal to 13. Okay, and our x here, or the birth weight, is equal to 141. Now let's write the question in or what is asked in using probability notation. So the probability of getting 141 or greater than or equal to 141. So this is the probability notation of what is being asked in the question. Now let's proceed to the first step. The first step here is for us to determine. So first step is to determine the z-score. So let me just type it. So determine the z-score that corresponds to 141. Okay. Now using the z-score formula for population data, we have z is equal to x minus mu all over sigma. And from here, let's just substitute the values. We have our x is equal to 141. So let me just put it here. 141 minus mu population mean, which is 109, all over 13. So if you do the math, basically have the answer here is 2.46. Just verify it using your calculators. So that's our first step. Now let's proceed to the second step. Just change this. Okay. Now the second step is for us to illustrate the normal curve and determine the area that we're looking for. The area that we are looking for. Just put this. We are looking for. Okay, so here we just make this a little bigger and let's insert an image of a normal curve that will be guided. Okay, here we have our normal curve, and let's try to locate where 2.46 is. So basically you will see this above the mean, positive 2.46. So it's somewhere there. Okay, let me just put an arrow so that that's 2.46. Okay, now let's go back to the probability notation. Okay, this is the probability is going to be more than, equal to, or more than 140, or greater than, equal to or greater than 141. So we're looking for this area. So beyond, so this area sorry, this is area shaded with red. Okay, that area. That's what we're trying to look for. Now, using our Z table, we know this area. Okay? From 0 to 2.46. And in the Z table, this is equal to 0.4931. Can you just verify? Okay? That's the area that corresponds to 2.46. Again, let's remember that our point of reference here is from the mean. So basically the area that I'm shading now with the green is 0.4931. Now, this will lead us to our third step, which is to the third step. Since we have both the areas, the area which 2.46 covers and the area that we're looking for, which is beyond 2.46. So what we need to do is just to subtract. So here, third step is to subtract the entire area above the mean, entire area above the mean, which is 0.5000 by the area which 2.426 covers. So, and we know the area which corresponds to 2.46, or let me just rephrase this. Okay, which, oh sorry, let me just rephrase this, which corresponds to 2.46, corresponds to 2.46. Okay, so remember we have the entire area above the mean, this entire area, this is equal to 0.5000, right? And that's what we 0.5000 minus 0.4931 to get the missing area, or the area shaded with the red. 500 minus 0.4931, and that's basically the answer is 0.0069. Okay, that's now our final answer, but we have to write our incomplete thought or sentence. So let me just write it here. Okay, therefore the chance of obtaining, ergo the chance of obtaining, oh no, there you go, chance of obtaining a birth weight of 141 ounce or heavier is, put it in red, 0.0069, or in percent is this is 0.69%. Okay, and that's our final answer. Sorry, just put it inside of, okay, that's our final answer.